Hi everyone, today we are going to talk about MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor, which is currently not only the most common type of field effect transistor, but it is also considered to be the most manufactured item in human history, with billions being produced on each modern CPU. So, why are they as common as they are today? You see, they use less power and have higher switching speeds than other transistor types. They can also be easily miniaturized and packed into high densities, making them perfect for integrated circuits. Not only that, they require relatively simple manufacturing and processing, which is a very important factor for industrial businesses. Today, they are basically used to control conductivity, or how much electricity can flow between its source and drain terminals based on the amount of voltage applied to its gate terminal. This property makes it so that MOSFETs can be used as a switch to turn on and off another circuit or other transistors, forming the basis of digital logic. They can also be used to vary the amount of conductivity for analog circuits and act as signal amplifiers. Of course, there are a lot of types of MOSFETs that exist out there, but for this video we'll be focusing on the LDMOS technology, which is a type of planar double diffuse MOSFET used in amplifiers, including microwave power amplifiers, RF power amplifiers, and audio power amplifiers. Although RF LDMOS devices are mainly used in mobile networks, enabling the majority of the world's cellular voice and data traffic, there is also one very important medical device that utilizes RF LDMOS, the Mighty Magnetic Resonance Imaging Machine, or MRI. The way an MRI works is that it uses a large magnet and radio waves to look at organs and structures inside your body. Do you know what the RF in RF LDMOS stands for? That's right, it's radio frequency. To produce said radio waves, RF LDMOS will be used to make radio frequency or RF coils, which are an essential MRI hardware component. These coils are basically the antennas of the MRI system, which can directly impact the spatial and temporal resolution, sensitivity, and uniformity in MRI. They have two main functions: to excite the magnetization of the large magnet by broadcasting RF power, and also to receive the signal from the excited spins within the body. It is because of this component that we are able to obtain cross-sectional MRI images for medical diagnosis. Of course, to produce these radio waves, we need the RF LDMOS to produce a high output power with high efficiency and low thermal resistance as well. An example of an RF power MOSFET for MRIs would be one from ST Microelectronics, where it only requires a 100 volt supply voltage to output up to 1200 kilowatts of power. It also has an efficiency of above 60% and lower thermal resistance, which is important for the long-term performance and operating costs of the machine. To conclude, MOSFETs are without a doubt one of the most important electronic components today, and it is no different in the medical field, where almost every medical device utilizes its technology, such as pacemakers, X-ray machines, defibrillators, hearing aids, and more. Even if we were just to look at MRI machines, without MRI scans it would be much more difficult to diagnose a variety of conditions in a non-invasive manner, especially conditions related to the brain and spinal cord. Thank you so much for watching this video, and be sure to leave a like and subscribe if you enjoyed it.